According to the James Webb Telescope's photos, humanity is definitely headed towards a future similar to that of Star Trek, but are scientists going to stop there? Probably not. As a new phase of space exploration appears to be at hand, we're coming closer to space travel with images of a new dwarf galaxy discovered by the James Webb Telescope. Stay tuned to find out more. Firstly, the lonely dwarf star spotted by the JSWT. A close-by dwarf galaxy has been captured in an astonishingly detailed image by the James Webb Space Telescope. The near-infrared perspective offers astronomers the most in-depth look yet at a star landscape that may provide them with the best way to learn more about the early universe. The picture depicts a variety of stars, with the isolated Wolf-Lundmark-Melotte dwarf galaxy, which is around 3 million light-years away from and about 1/10 the size of the Milky Way. According to NASA, the WLM galaxy is fascinating to astronomers because it has stayed essentially isolated and has a chemical composition that can be compared to galaxies from the early cosmos. This is due to a phenomenon known as galactic winds, which cause the galaxy to lose many of these components. Even while WLM has been, in fact, throughout all the cosmic time, been producing stars, and those stars have been synthesizing new elements, some of the material is evacuated from the galaxy as the huge stars burst. Small, low-mass galaxies like WLM can have material pushed out of them by supernovas that are strong and energetic enough. Since you can use WLM to examine how stars develop and grow in tiny galaxies like those in the early cosmos, this makes WLM extremely fascinating. More on the telescopes trying to capture it. The Webb Telescope, the strongest space observatory to date, launched back in December 2021. It can see infrared light, which has a wavelength that is undetectable to the human eye and is used to catch feeble light from extremely far away galaxies. The WLM galaxy has been imaged by the Hubble Space Telescope and the retired Spitzer Space Telescope, but Webb employed its near-infrared camera, often known as NIRCam, to record it in unparalleled detail. Kristen McQuinn, an assistant professor in the Physics and Astronomy department, went on to say that we can see a vast number of individual stars of different sizes, colors, temperature levels, age groups, and stages of evolution. The telescope also shows interesting clouds of nebular gas within the galaxy, foreground stars within Webb's diffraction spikes, and background galaxies with neat features like tidal tails. A tidal tail is a galaxy's narrow tail of stars and interstellar gas. Of course, the sight is richer and deeper than our eyes are capable of seeing. Even if you could see infrared light and were on a planet in the center of our galaxy, you wouldn't be able without some kind of bionic eyes similar to the James Webb Telescope. Finally, how is this image important? Even if you can't figure out its significance, you can appreciate that it's a pretty beautiful image. NASA's official Webb Telescope account wrote on Twitter that Webb's NIRCam images makes the whole sky glitter when compared to earlier space observatory photographs. Some stars that are visible in this most recent Webb image are low-mass stars that were created in the early cosmos and are able of surviving for billions of years. We can learn about what events unfolded in the very distant past by figuring out the characteristics of these low-mass stars, such as their ages. Reconstructing the galaxy's star formation history is the primary scientific goal. Given that low-mass stars can last for billions of years, some of the stars in WLM that are visible now formed in the early cosmos. We may learn more about these low-mass stars, such as their ages, so we can learn more about what was happening in the incredibly distant past by observing high redshift systems where we can view galaxies as they were when they initially formed. We can learn a lot about the early formation of the galaxies. In other news, the hunt for habitable exoplanets. The James Webb Telescope's search for planets that potentially host life could be assisted by a new framework for the study of planets outside the solar system. Astronomers have studied the far-off planet TRAPPIST-1e, which resembles Earth, to create a framework that will assist researchers in figuring out whether any planets outside of the solar system could sustain life or be suitable for human habitation. One of the 7 planets in the TRAPPIST-1 system, TRAPPIST-1e, revolves around a calm M-dwarf star 39 light-years from Earth. The newly photographed galaxy system has become the main target for the hunt for life anywhere in the universe, since all of these exoplanets are believed to be rocky or terrestrial worlds that are comparable in size to Earth. The TRAPPIST-1e exoplanet, which is one of the most possibly habitable exoplanets ever discovered, will be the focus of close observation by the James Webb Space Telescope during the course of the upcoming year. In this new study, a computer model was used to mimic mimic the climate of TRAPPIST-1e, a planet that is roughly identical to the size of Earth but has 40% less mass. The planet is suited in what is known as the habitable zone, an area where the temperatures are sustainable for liquid water to exist. Next up, how scientists use the data from the James Webb Telescope. The scientists next made a comparison between TRAPPIST-1e and Earth by examining how the simulated exoplanet's climate responds to increases in greenhouse gases, including the impact of carbon dioxide on extreme weather events and the rate of changes in weather. Asaf Hochman, the project's leader and a professor at the Hebrew University of Jerusalem's Freddie and Nadine Herman Institute of Earth Sciences, said in a statement that these two variables are crucial for the existence of life on other planets and are now being studied in depth for the first time in history. The atmosphere of TRAPPIST-1e is significantly more susceptible to greenhouse gases than the atmosphere of Earth, according to research by Hochman and his colleagues. This suggests that more extreme climate changes than would be observed on Earth could arise from an increase in greenhouse gases in TRAPPIST-1e's atmosphere. The fact that TRAPPIST-1e is tidally locked to its star may account for this heightened sensitivity. As opposed to Earth, which rotates as it orbits the Sun, exoplanets have one side that is always facing the star, known as the day side, and this side is constantly exposed to radiation. Without sending a spacecraft crew to physically visit them, Hochman said, the study approach we devised, together with observational data from the James Webb Telescope, will enable scientists to efficiently examine the atmospheres of many additional worlds. Future judgments concerning which planets are sustainable for human colonization and potentially even the search for life on such planets will be made with more knowledge thanks to something like this. Hochman and his team believe that studying the climate fluctuations of an Earth-like exoplanet like TRAPPIST-1e could aid in our understanding of the global climate changes that are now taking place. Additionally, research into these circumstances may aid in improving scientists' comprehension of potential future changes to Earth's atmosphere. Moving on to, can we spot alien life with the telescope? Exoplanet research, or the study of planets that orbit stars other than our Sun, is currently undergoing major changes. Soon, we will be able to have our first look at the environments on rocky, potentially Earth-like worlds outside of our solar system. Perhaps there is life on one of these far-off planets. Could we ever find it, though? The makeup of a planet's atmosphere might contain traces of life that we can look for. We can look for signs of various gases and starlight as it travels through a planet's atmosphere using a method that separates light by its wavelength. Finally, what happens if we end up finding alien life? JSWT is already used to observe the atmospheres of exoplanets. Despite this strength, transmission spectroscopy will still be difficult to use to examine rocky planets with temperate atmospheres that are dominated by nitrogen or carbon dioxide. Compared to the signals we have successfully observed in hot gas giant atmospheres, the signals we anticipate from these planets are significantly weaker. If we are fortunate enough to spot starlight absorbing gases in the atmosphere of a rocky exoplanet, we still need to measure their concentration in order to draw conclusions about their presence. The signals need to be properly disentangled because they can overlap, making this task quite challenging. Even if we successfully identify and test one of our potential biosignature gases, we can't actually say that we have found extraterrestrial life. JSWT is only now operating up a fresh, rich laboratory of planetary atmospheres, and as we explore, there's a good chance that many of our preconceived notions will turn out to be incorrect. It would be kinda naive to think that every time we find something strange, aliens are to blame. A JSWT biosignature detection would be a helpful clue, but there is still a ton of work to be done. That's a wrap for this video. Thanks for watching. What did you think of the latest images of the lonely dwarf galaxy, and how soon could we be visiting it? Let us know in the comments below. Make sure to give this video a thumbs up and subscribe to our channel for more videos like this. See you in the next one.